Let's go ahead and look at another example from section 9.2 on regression. So this is problem 3 from the homework in that section. And it says that the accompanying data are the number of wins and the earned run averages, okay, which is the mean number of earned runs allowed per 9 innings pitched for 8 baseball pitchers in a recent season. So we're going to find the equation of the regression line, and then construct a scatter plot of the data and draw the regression line. And then we're going to use that regression line to predict the value of y for each of the given x values, if meaningful. Okay, and if the x value is not meaningful to predict the value of y, explain why not. Okay, let's go ahead and open up the data. And let's go ahead and copy it. And we're going to go ahead and go to StatCrunch and paste that data. Okay, so we got the wins in the X column, and then the earned run average in the Y column. Okay, so X is the independent variable, number of wins, and then Y is the dependent variable, the earned run average. Okay, let's go to the stat menu. Go to regression, and then select simple linear. Okay, the X variable is the number of wins, and then the Y variable is the earned run average. Okay, and we're going to select fitted line plot. And then there are other options, but let's not worry about what those are. Okay, and what we're looking for is the slope and y-intercept of the regression equation. Okay, so this number here is the slope, so negative 0.180. Okay, so it simply says round to 2 decimal places as needed. Okay, so to 2 decimal places, the slope is negative 0.18. So negative 0.18. Okay, and then the intercept, the y-intercept would be 6.31. Okay, so that 0 gets rounded up to a 1, so 6.31 is that y-intercept. Okay, so the regression equation is y hat equal to negative 0.18x plus 6.31. Okay, let's go back to our results, and on the next slide should be the graph. Okay, these are the individual data values. Okay, and if you put your cursor over it, you can see the number of wins, x, and then the earned run average, y, for each of the blue points. Okay, and then the line shown in red is the regression equation, which has a sloping downward pattern, so it has a negative slope. All right, so it seems to follow the pattern of the data, which also slope downward from left to right. Okay, so we're going to select the graph that most resembles the one that we have here in StatCrunch. Okay, so it appears that this graph has a slope that's too steep. Okay, but this graph seems to match the equation of our line and then the scatter plot of the data. Okay, you can always double check it. All right, so select the most appropriate answer choice, in this case, answer choice C. Okay, so based on that equation, all right, we're going to predict the earned run average, ERA, for 5 wins, okay, if it is meaningful. Okay, remember in the book, it says that the equation of a regression line can be used to predict y values for certain x values. Okay, so prediction values are meaningful only for x values in or close to the range of the observed x values for the data. Okay, that's the important point that you want to highlight. Okay. So if we go back and look at our data, right? When you determine the range of the x values, okay, you look at the smallest x value and then the largest x value. Okay, so it appears that the smallest x value is 9, the largest x value is 20. Right, so when we use the regression equation to make predictions, right, any x values that we plug into our regression equation should be between 9 and 20. Okay, so in other words, we don't want to make predictions, right, where the x value is greater than 20, right, or less than 9. Right, so in other words, our predictions, okay, for x values that are outside of the range of the data, right, so in other words, x values that are either larger than the largest x value in your data set or smaller than the smallest x value in your data set, okay, are outside the range of your data set and are not meaningful. Okay, so for 5 wins, right, we see that 5 is below the smallest x value. Okay, so it is not meaningful to make a prediction based on that x value. Okay. Okay, so in other words, so it is not meaningful to predict this value of y because x equal 5 is outside of the range of the original data. Okay. Now, the x value that you want to make a prediction for doesn't necessarily have to be one of the existing x values. Okay, it could be, right, but it doesn't have to be, as long as it's within the range of your data set. So as long as it's between the smallest data value and the largest data value, right, you can make a prediction on. Okay, so since 5 is outside the range of the data set, it is not meaningful to predict its y value. So let's go and check our answer. Okay, in part B, we want to predict the earned and run average for 10 wins. Okay, if it is meaningful. Okay, remember the smallest x value is 9 wins, largest is 20 wins. So 10 is definitely between 9 and 20. So we can make a prediction based on that value. Okay, so x is 10. All right, so that's what we're going to put into our calculator. So negative 0.18, okay, multiplied by 10. Okay, so remember the slope always multiplies your x value. So negative 0.18 times 10 plus 6.31. Okay, so we would expect an earned run average of 4.51. Okay. So for 10 wins, we would expect an earned run average of 4.51. Okay. So it says round to 2 decimal places, so our answer is y hat is equal to 4.51. So remember, y hat is your predicted y value. Okay, if you're a baseball fan, perhaps you already know that earned run averages can be rounded to 2 decimal places, right? So earned run averages can take on decimal values. Okay. All right, part C says predict the ERA for 19 wins if it is meaningful, and then select the correct answer choice. Okay, so 19 wins is definitely within the range of our data set, so it's between the smallest and largest x values. Okay, so we're going to plug those into our regression equation. Okay, so negative 0.18 multiplied by 19 plus 6.31. Okay, and we see that we get a lower earned run average, so 2.89. All right, so remember the regression equation slopes down. So let me open it back up. Right, so as we increase the value of x, right, we would expect a lower number for the earned run average. Okay, and if we decrease the value of x, we would expect a higher earned run average. Okay, so that follows with what we see in the graph of our regression equation. Okay, so the answer part C would be 2.89. So y hat is equal to 2.89. Okay, so this is the last part of the question, and it says predict the ERA for 15 wins. Okay, if it is meaningful, and then select the correct answer choice. Okay, so obviously 15 is between 9 and 20. Okay, so we're going to plug that into our regression equation. All right, to figure out what the predicted earned run average is. Okay, if the team has 15 wins, or rather, if that pitcher had 15 wins. So, all right, so we're going to type in negative 0.18. Okay, multiplied by 15 plus 6.31. Okay, and we get an earned run average of 3.61, which is slightly higher. Okay, than the earned run average if there were 19 wins, okay, which is expected. Okay, so y hat is equal to 3.61. So in other words, the greater number of wins, right, the smaller the earned run average is. Likewise, the smaller the number of wins is, the higher the earned run average is. Okay, but let's go ahead and check our answer. All right, and we've correctly completed problem 3 in the homework. Okay, so problem 5 says to use the data in the table below to complete parts A through C. Okay, this is the table of data values. Let's go and copy it. And we're going to go to Stack Crunch. Okay, so going back to the problem, it says construct a scatter plot of the data. Okay, so we should know how to do scatter plots by now. So I went ahead and did it off camera. So this is our scatter plot. So we're going to select the graph that most closely matches our scatter plot. So it looks like choice B. Okay, and we're going to click continue. And part B says identify any possible outliers. Okay, so in a scatter plot, an outlier would be a point or data value, or paired value, I should say, a paired data value that's far away from the other data values. Okay, so it's very clearly this point here in the lower right corner. Okay, which has an x value of 44 and a y value of 6. If you put your mouse over it, you can see the x and the y value. Okay, the y value is on top, x value is on the bottom there. Okay, so that'd be the outlier. So the point 44, 6 may be an outlier. Okay. All right, and then it says determine if the point is influential. It says the change in the slope or intercept is significant if it is larger than 10%. Okay, so what we're going to do to answer this question is we're going to construct the equation of the regression line based on the data as it is with the outlier. Okay, so to do that in an existing scatter plot, okay, you're going to go, so you're going to do what I just did. Click on options and then edit. Okay, and then where it says overlay polynomial order, okay, from that menu we're going to select 1. Okay, and best fit will be selected by default, so we'll leave that selected and then click compute. And then we'll see the equation of that, or then we'll see the graph of that regression line, and then it tells you the equation. Okay, so this is something you might want to write down. So the y-intercept actually comes first, so it's 38.07, and the slope is negative, which is negative 0.73. Okay, so I've made a note of that regression equation with the outlier. Okay, so now we're going to attempt to do the regression equation without that outlier. Okay, so again, we've identified this point as being the outlier. Okay, which happens to be on the line there. So it was 44,6. So if we remove that particular data point, okay, and then redo our scatter plot. Okay, we want to see how much it changes that regression equation. Okay, so this is the new regression equation. So again, let's make a note of it. So 38.28 or 29 is the y-intercept, and then negative 0.75 is the slope. Okay, so we can see that by removing the outlier, right, it slightly changed the slope of the line and slightly changed the y-intercept. So we're going to answer accordingly, right? So the point is not an influential point because without the point included, the slope and y-intercepts are not significantly